So my name is Rahel Amarshi, and I'm from Tanzania in East Africa. I am a solutions architect based out of New York City, working at MongoDB. So today, I'm going to showcase using MongoDB with AI tools to build the next generation of geospatial applications. So let's meet a fellow developer named Dylan. Dylan is a full-stack developer working at TZ Media Corp in their restaurants department. The biggest undertaking of their restaurants department is their Restaurant Finder application. And this Restaurant Finder application involves matching users to specific restaurants and helping them provide reviews and create a full experiential application for users to interact with. So Dylan has been provided a task. Dylan's task is to optimize this Restaurant Finder, make their queries lighter, and in turn, make the responses faster to the end users. Not only that, but Dylan has also been asked to add personalization, since personalization is the name of the game when it comes to modern applications. Dylan knows of MongoDB, but has never used it. Probably like many of us in the room, right? How many have heard of MongoDB, familiar? There we go. Dylan also loves to code in Python. I know we have many Python coders in here, so. All right, so the first thing Dylan does is plot out his challenge. Dylan knows that for this Restaurant Finder application, there's going to be location-based search for listing out all the restaurants in a vicinity. There's going to be real-time routing of users to restaurants. There's also going to be mixed data formats coming in from various menus at different restaurants. And then obviously, the most quintessential part of their application is providing filters to their customers to be able to filter through their data. Last but not the least, personalization at scale. This application is supposed to go nationwide and possibly, if it hits as a success, globally as well. And so each user needs to be able to have a set of recommendations that are custom to their preferences and their interactions with the application. So as Dylan is evaluating his tech stack, Dylan builds out a requirements list. Dylan is looking for something that has a flexible data model that can take in geospatial data, date types of data, object data, and many other such data types. Dylan also needs geospatial indexes to route users to restaurants. And Dylan may also need a search engine for things such as providing multifaceted search to their users, filtered by cuisine type, ratings, reviews, and so forth. And then obviously, an AI-led personalization effort to reduce the human effort and still create a more personal experience for each user. Lastly, but not the least, Dylan has been asked by his data insights team to make the user interaction data usable internally to make the app experience better. So Dylan could go this way, where he has his current application stack. And in his current application stack, he could add a specialized geospatial database, he could add a search engine, and he could build 2 ETL pipelines to add to that stack, and then he could do the management of data flowing from their original application all the way back into their new search engine and their new geospatial data, and then he has to now maintain those 2 technologies as well as their ETL processes. Did I confuse a lot of people? Very complicated, right? So this definitely does not sound like the ideal way, because it increases the maintenance of the tech stack and increases tech debt. And generally, no other developer like Dylan would want to go through this. So how can MongoDB help? MongoDB's document data model lets you store a wide variety of data types, including geospatial data, all in one single rich document. By storing geospatial data right next to other contextual data, Dylan has unlocked the opportunity for AI-led personalization. with the support for native geospatial indexing, you can also achieve faster queries at scale. So overall, the document model looks to provide a natural, flexible, and faster experience, not only for the developer, but also for the end users. In addition to the document data model, MongoDB offers Atlas. Atlas is a fully managed, cloud-based developer data platform. And this platform has been battle tested by about 57,000 plus customers today. Atlas offers functionality such as multi-cloud deployments, global cluster deployments, automated scaling, backups, maintenance, as well as high availability for all your applications. With Dylan's ever-evolving business needs, as we all have, one day we're told to do something and the other day we have another use case to tackle. Dylan can find assurance in knowing that MongoDB offers a native support that is built in for search, vector search, time series, and many other use cases. So in this way, now we know that what MongoDB is and what it has to offer. So let's take a look at how theoretically Dylan would build out this POC. So first things first, MongoDB provides client drivers which make working with your database intuitive. So as mentioned, Dylan codes in Python, so Dylan will use the Python client driver. Dylan also learns about aggregation pipelines. Aggregation pipelines in MongoDB are streamlined methods of querying and working with your data. In an aggregation pipeline, each functionality is broken down into individual stages. And these stages do only one piece of functionality for ease of debugging. So let's take this example that we have on screen here. We have customer data that is entering the aggregation pipeline, and the first stage of match is being applied. In this stage, each customer with a status of A is being filtered through the pipeline onto the second stage. The second stage being the group stage. This is where customers are being grouped by their customer ID, and then their total amount is being summed up and delivered as one packaged response. And so there you have it, an easy to debug aggregation pipeline. That aggregation pipeline has a wide variety of stages. So you can go into stages such as GeoNear, which I'll explain further, search for text and vector search, as well as match, merge, and many others. You can also run things like arithmetics and conditional formatting through the operators provided. So now that we know some fundamentals about the aggregation pipeline and how MongoDB stores data, Dylan takes the location of a restaurant in geospatial coordinates and can store it right in the location object alongside the address. Next, Dylan can run the GeoWithin stage in the aggregation pipeline. In the GeoWithin stage, Dylan basically can provide his customers with a list of restaurants in the specified vicinity. If it's a polygon, if it's a box, if it's a center, a circle, and so forth. Dylan can also run the GeoNear stage in the aggregation pipeline, which lets him provide his users with a list of restaurants near them. And moreover, it gives the customizability in the query to specify a minimum and a maximum distance. In addition to the aggregation pipeline, running those with a rich indexing capability that MongoDB provides, such as compound indexes, and in this case, geospatial indexes, Dylan can run these queries with confidence at high scale. All right, so quick POC time. Now we know all the fundamentals. Let's see how Dylan went about building his POC and sped up his POC delivering process with the use of MongoDB and other AI tools like Claude LLM. So here is the MongoDB Atlas user interface. This is where Dylan can see his sample in which lies the restaurant's collection of documents. In this document, you can see that a restaurant's geospatial coordinates are stored right next to other contextual information such as the cuisine type, the name of the restaurant, and so forth. Dylan's main task for this POC is to run their most commonly run query, which is to provide a list of restaurants to the end user given a specific cuisine type near them. Given the information that we've just learned in the presentation, Dylan has some idea to get started, but would really like to speed up his development process using AI. How does he do that? Using MongoDB's provided MCP server, Dylan is able to connect his dataset to AI agent tools like Claude LLM, which then can provide him with MongoDB best practices and even build out queries for him. Let's take a look. Dylan inputs his query, which is, based on the sample restaurants collection, please take my current coordinates and suggest me the best pizza restaurant near me. Here, the LLM prints out the number of pizza restaurants in the dataset being 1,631 here. And then, once Dylan provides his current coordinates, he's provided a fully built out aggregation pipeline which he can use to build out his Mongo query. So, as you can see here, this query compiles all of this into one lightweight query. Step 1 is the GeoNear tag, which allows him to do a location-based search, and then he is able to filter out by the cuisine type, which is pizza. The LLM also provides a best practice recommendation and acts on it for Dylan, which is to create a geospatial index which is supported by MongoDB. It creates a 2D sphere index in the restaurant collection database and then runs the query with a sort function to be able to sort the results neatly for Dylan. The output is as follows. As you can see, it provides the best pizza places near Dylan, provides the walking time it would take to get to those restaurants, and even highlights the closest one for Dylan. With AI and MongoDB, Dylan was not only able to speed up his development process, but was also able to optimize his restaurant finder by running a lighter, faster, and more natural query. All right, so we just saw the use of the aggregation pipeline to run both geospatial and other type of contextual queries and its power to deliver. We also saw the use of AI to speed up that delivery process for a lot of us who are familiar with MongoDB but may not have dabbled at an expert level. Let's just for a moment take a look at what other customers at Mongo are building with the power of Mongo and even AI. So GE Capital partnered with Mongo to modernize their fleet management and analytics platform. They chose MongoDB to replace 2 legacy systems and experienced 85% faster response times. They were production ready in 90 days. And with that, they also were able to target other use cases outside their targeted use case, which was to reduce energy consumption within their fleets, given the extra data insights that they were able to unlock with all the data being in one single rich document. Let's also take a look at Mercedes-Benz Group that partnered with MongoDB to power their telediagnosis application. This application provides vehicle owners real-time data on their vehicle's health and also provides almost near real-time event notification on any warnings or loggings that are needed to be provided to the customer, giving the customer a more unique, personalized experience. One of my favorites, Epic Games. They powered a 125 million players application to get a constant feedback loop on how their players are resonating with the application. This this was a very successful initiative because it gave the developers up-to-the-minute understanding of how a user is interacting with the game and what their satisfaction levels are while they're playing the game. So let's see how you can power the next generation of applications with MongoDB. Please feel free to get in touch with me to get started. We would love for you to scan the QR code and get in touch with us. I would love to see what kind of applications you are to build next with MongoDB. Thank you so much for your time, and I'll be sticking around for some questions.